Good afternoon, everybody. We are going to be talking about the 1.4 notes, which is solving multi-step equations and inequalities. So this is just going to be an expansion over the notes that we talked about last time, where we only did 1 and 2-step equations and inequalities. Our learning target today is I can solve linear equations / inequalities in mathematical and real-world situations using multiple tools and representations. I can explain my reasoning using logical arguments and determine reasonableness of solutions. We have 2 vocabulary words today. The first one is special cases, which is also known as identities. And this is a specific equation that is always either true or never true. And when we get to an example of a special case, I will show you what that looks like. And then the next vocab word that we have is a compound inequality, which is a mathematical statement that combines one or more inequalities into 2. And again, when we get to the compound inequality, I will show you what that looks like. Okay, so since we've already talked about how to solve an equation, we're just going to jump right on into the solving equation problems. Okay, some of these might still be 2-step equations, but generally they're going to be more than 2 steps. So when I look at the first problem here, it wants me to solve for x, and as a reminder, we have to do SADMEP. So in order for me to solve for x, I have to do PEMDAS backwards, okay? I need to get rid of the 3 that is with the x, and then I need to get rid of the 2 that is in the front of the parentheses. So right now, x and 3 cannot be combined because one is an x and one is not. But not only that, they're trapped in a set of parentheses, so I cannot just try to subtract 3 out of the parentheses. It doesn't work like that. So what I'm going to have to do instead is figure out how to get rid of the parentheses while keeping the integrity of the inside of the parentheses. So what I'm going to do is actually the distributive property, because I have a number on the outside that I can multiply to get into those terms within the parenthesis to make the parenthesis go away. So 2 times x is 2x, and then 2 times 3 is a positive 6. So when I distribute, my parentheses go away, and now I am left with 2x plus 6 equals 9. From here, I would follow the normal steps of solving. I would subtract 6 first. So I now have 2x equals 3. And then I would divide both sides by 2. The directions tell me to leave my answer in exact form, so I'm going to leave this as x equals 3 over 2. Moving on to number 2, I again have a set of parentheses that I cannot just take things out of. So what I'm going to have to do here is distribute this -1 that is in front of the parentheses. This 3 over here I'm not going to do anything with just yet, so I'm going to bring it down. And then I've got -1 times y, which is negative y, and then -1 times -6, which is positive 6. So now on the left-hand side, I can actually go ahead and simplify. I've got this 3 and this 6. They're on the same side of the equal sign, so I'm just going to add them like I see them. 3 plus 6 is 9. So I have 9 minus y equals 12. From here, I would subtract 9 on both sides. That'll cancel. And we have that -y is equal to 3. Now, I can't leave my answer like this because my variable is actually not technically by itself. There's a -1 in front, and I'm multiplying by -1. So in order to get rid of that, I'm going to divide both sides by -1, and I get y is equal to -3. And I'm sorry if you hear weird noises in the background. My dog is in here with me. Okay. Moving on to number 3, we haven't seen a problem like this where we have a variable on both sides of the equal sign, but the good news is that we can move variables like that 3x and that 5x the same way that we would move anything else. Now, I know that we're in the habit of moving our numbers first, but I am going to suggest that you actually start by getting your variables on one side first if you can. So when I look at this problem, I don't want an x to be on the left and on the right. I want to move that 3x from the right-hand side over to the left-hand side. And I don't want to break up the 3x. I don't want it to be a 3 by itself and an x by itself. I want it to move as a unit. So what I'm going to do is subtract 3x on both sides of my equal sign because that's technically a positive 3x. And since I need the whole thing to go, I'm going to subtract the whole thing. And I'm going to subtract it by the thing that it is like. It is like 5x. So right now I've got 5x minus 3x, which gets me 2x. I'm going to bring down my plus 1, and I'm going to bring down that positive 2 on the right-hand side that I haven't done anything with. From here, I'm going to go ahead and subtract 1 on both sides. I've got 2x is equal to 1. And then in order to separate the 2 and the x, I am going to divide both sides by 2. And we get that x is equal to 1/2. Looking at number 4, there's a whole lot of stuff going on here. So I've got a set of parentheses. I've got 2 m's technically on the left side of my equal sign, and then I've got an m on the right side of my equal sign. So when I look at a problem like this, my instincts tell me that I need the parentheses to go away because there's stuff on the inside of the parentheses that I need to be able to do things with. And like I told you before, you can't just rip things out of the inside of a parenthesis. So my first step is going to be to distribute this positive 6 into the parenthesis. So I've got 9m plus 6m minus 6, and that is going to equal 8m plus 3. Now that I'm here, when I look at the left side of my equal sign, it looks like I can go ahead and combine some like terms, this 9m and this 6m, because they're on the same side of the equal sign. I just want to combine them like they are. 9 plus 6 is 15, so this will be 15m minus 6 equals 8m plus 3. Now I've got an m on the right side and the left side, and I want them together on one side. So I'm going to subtract 8m because, again, it's a positive 8m right now. That'll be 15, 14, 13, 12, 11, 10, 9, 8, 7. That'll be 7m minus 6 equals 3. From here, I'm going to add 6 to both sides. Oh my gosh. 7m equals 9. We will divide both sides by 7 to get m by itself, and I end up with m equaling 9 over 7. Now, I know that that's a gross number. You guys don't like looking at a number like that, but that is a simplified answer in exact form. And it's okay to have fractions. It's not just because you get a fraction doesn't mean your answer is wrong. Okay, I'm going to move down to number 5. I've talked about how to do a problem like this before. So this one's a little bit different, though, because there's a 1 in front of my m. But I am going to have to do the distributive property twice, one on the left-hand side of my equal sign and one on the right-hand side of my equal sign. So I'm going to go ahead and distribute this 2/3 into the parentheses. So 2/3 times 1m is just 2/3 m. And then when you do 2/3 times -9, remember you multiply by the numerator and then divide by the denominator. So -9 times 2 is -18. -18 divided by 3 is -6. I'm going to do the same thing on this side. 1/3 times 1m is just 1/3 m. And then when I multiply over this way, I've got -27 times 1 divided by 3, which will get me, I'm going to move this down a little bit, hold on. There we go. -27 times 1 is -27 divided by 3 is -9. Okay, I'm going to subtract 1/3 m to bring it to the same side as my 2/3 m. So I know we haven't done any kind of subtraction of fractions. Just as a reminder, you can add and subtract fractions as long as their denominator is the same. So right now I've got 2/3 minus 1/3. You leave the denominator, whatever it is, and then you subtract the numerator. So 2 minus 1 is 1. So this will be 1/3 m minus 6 equals -9. And then you can do that in the calculator if you need to. I'm just reminding you how to do it without using the calculator. We will then add 6 to both sides. So I have 1/3 m equals -3. In another set of notes, I told you guys that 1/3 m is actually the same thing as 1m over 3, and visually this is better to me because I can see that I can go ahead and multiply both sides by the denominator, and I am left with m equals -9. And you can put a 1m in front, but it doesn't change your answer because if you divide by 1, you're still just left with m equals -9. Alrighty, let's move on to number 6. I'm going to have to do the distributive property here, and I'm going to have to do the distributive property here. I'm going to go ahead and drop my line. This will be 7w minus 2w plus 18 equals 4 minus 8w minus 16. On the left-hand side, I can combine 7w minus 2w, which is 5w. And then on the right-hand side, I can actually do 4 minus 16, which is negative 12. And now that I'm here, I would like to get all of my w's on one side. I'm going to go ahead and add 8w this time. That was a minus 8w, so I'm going to do the opposite, which is addition. 8, 9, 10, 11, 12, 13. So this is 13w plus 18 equals negative 12. Subtract 18 on both sides. We get 13w equals negative 30. Divide both sides by 13. And as disgusting as this answer is, negative 30 over 13 cannot be simplified. So there's my answer in exact form. All right, I'm going to go ahead and skip a couple of these just because I don't want this homework or these notes to take a long time, and they're already taking a bit of time. But I do want to talk to you about number 9. So move here. The answer key to this will be completed, so you can go back and look at it if you want to do the other problems, but I definitely want to go over number 9 with you. So this one actually is kind of a going backwards with being easier than some of the other ones, but there's a reason I want to go over this one. If you look at the right-hand side, you can actually go ahead and take care of the 7x minus 2x, which will give us 5x. Now that we're here, I'm going to move my 5x from one side to the other. And when I do that, I'm actually left with no x's. My variables have disappeared, which means that I have ended up with what we call a special case. And I'm going to scroll back up in the notes, so bear with me when I do that. So remember, a special case is a specific equation that is always either true or never true. So there's two types of special cases. You can either have infinitely many solutions or you can have a no solution. And it depends on what you get when your variables disappear. So I would put a star next to this one because your variables are gone. You're going to end up with a statement, and your statement is either going to be a true statement or it's going to be a false statement. So this statement is 3 is equal to 3. That is actually true, which means that we have infinitely many solutions. Infinitely, okay, there we go, many solutions. This is the answer, not 3 equals 3. What this means is when you get an infinitely many solutions, that means that you can plug in any value for x that you could ever dream of. And when you plug it in, it's always going to be true. Your equation will always be something that is true. So for example, let's say that just for funsies, I pick that I want my x to be 7. Okay. I'm going to plug in 7 anywhere that I see an x. And I'm going to go ahead and simplify like I would do with PEMDAS. So this will be 35 plus 3 equals, that's 49 minus 14 plus 3. This is 38 equals 49 minus, 49 minus 14 is, 49 minus 14 is 35 plus 3, which is 38. Look at that. And I could plug in any number. I just chose 7 randomly, but you could pick any number and plug it in, and you're going to get the same thing every time. Your equation will always be true no matter what you plug in. So we call this an infinitely many solutions answer. This is a special case, okay? All right, so now that I've talked about that one, let's talk about, I'm going to skip down to number 11. So now we have an inequality that we're working with, which is fine. I'm still going to go ahead and drop my line for this inequality, and then I'm going to solve it like I've been solving all of these other equations. I'm going to do negative 4 times 2m and then negative 4 times negative 7. This will be negative 8m plus 28. Do not forget your inequality symbol. And then we have to distribute the 3 over here. That is a big number. 3 times 52 is 156 minus 12m. Okay, now, from here, I'm going to add 12m to both sides. And you get 4m plus 28 is greater than 156. We are going to subtract 28 on both sides, and we get 4m is greater than 156 minus 28 is 128. I will divide both sides by 4, and we get that m is greater than 32. We didn't need to flip our inequality symbol because we did not do any kind of multiplying or dividing by a negative number, so we are good. Okay, so that is the idea behind solving multi-step equations. You have done this before. You have done this in middle school. This isn't brand new to you. However, I just wanted to kind of go back through with you to remind you how to actually do this. Okay, let's look at number 15. You need to go to CVS for a few small items and your parents gave you $40 to spend. You need to buy a water bottle but also want some nerd clusters. The water bottle will cost you $32 and each nerd cluster packet will cost you 70 cents. Write an inequality that represents the amount of money you can spend at CVS. So I know that I have $40 to spend. And that's the maximum that I can spend. I can spend less than $40, but 40 is the maximum I can spend. So when you think about an inequality and writing an inequality from a word problem, you have to remember that the alligator wants to eat the larger thing. Okay. And I know that's very elementary, but even as like an adult who teaches math, I have a math degree, like that is still what I remind myself of. The alligator eats the bigger thing. Okay. So since 40 is the maximum that I am allowed to spend, I'm going to have my inequality open up towards 40. 40 could be on the left side of your inequality or the right side. It doesn't matter. I like to put it on the left. I don't know why. It just makes more sense in my brain. Okay. Now I know that Nerds clusters are 70 cents per packet and I'm going to buy one water bottle for $32. So that is my inequality that I am setting up. Okay. It says how many nerd clusters can you buy? So now I'm going to take that inequality that I wrote and I'm going to solve it for x. That is the most annoying beeping noise. And I have 8 is greater than or equal to 0.70x. Divide both sides by 0.70. And we get 8 divided by 0.70. And that gets me 11.43 is greater than or equal to x. I have to flip this whole thing around, which means the inequality also has to flip. So this is going to be x is less than or equal to 11.43. Now, you cannot purchase 0.43 of a packet of Nerds clusters. So we're going to just get rid of that. And this is saying that you can buy 11 packets of Nerd clusters or less and stay within your $40 budget. Okay. All right, now let's talk about compound inequalities. Number 1 says, write an inequality for each of the following parts, then graph the solution. So it says, write an inequality for the statement, my children are over the age of 2. So if their children are over the age of 2, we're going to go ahead and create a graph. I'm going to put 2 in the middle. This is 3, this is 4, this is 1, this is 0. My children are over the age of 2. So I'm going to put a circle at 2, and then I'm going to squiggle this direction, okay? Because they could be 3, they could be 7, they could be 12. We don't know. We just know that they are over the age of 2. Part B says, my children are under the age of 15. So here we go. Here is 15, here is 16, here is 17, here is 14, and here is 13. If you are under the age of 15, that means that you're going to be somewhere in the 14, 13, 10 range, okay? So we're going to graph our inequality that way. So part A and part B are individual inequalities, okay? You have it, you graph it, you only have to graph one thing on a line. The next thing that I'm going to talk about, though, is a compound inequality. This says, write a compound inequality for the statement. My children are between the ages of 2 and 15. So what I'm doing is I'm basically combining both graphs for part A and part B into one graph. So it's going to look a little funky, okay, but just bear with me. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, whatever. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to put a 9 there. Okay, if you are between the age of 2 and 15, that means that you are going to be in this middle zone. There is nothing going this way. There's nothing going this way, and there's nothing going that way. Okay, this person's children are between the ages of 2 and 15. That means that they could be 5 and 10. They could be 2, or they could be 4, 5, 6, 7, 8, 9, 11, but they have to be between the ages of 2 and 15. And the way that we graph this is the shaded part of our graph is where all of the possible solutions would be. So all of the possible ages of our children, all the possible ages of our children are between 2 and 15. And this isn't going to make a whole lot of sense to you right now, but it will when we get into our next unit. Anyways, I'm going to go ahead and finish the rest of these that I did not complete up here, and they'll be in the answer key later for you to look at. But if you have any questions, go see your teacher during their scheduled tutorial times. Bye-bye.